Okay, for this problem, I'm going to assume that you have watched the lecture video or one of the other walkthrough videos about this kind of inventory cost problem. I'm not going to explain where each individual relationship comes from. Those are already covered in the other videos that have been done. So instead, we will start off with the units per run. Let's say we do 10,000 units per run. Then what I need to know is how many runs would be needed. Well, I need to make, what was it? 300,000 items. So it'd be 300,000 items divided by 10,000. I would need 30 runs. So the cost of prepping those runs is, where is it? $500. $500 and I need 30 runs. Okay, now for storage, I need to know the items that are stored. And this is an average. So on average, the items that are in the warehouse at any point in time is half of the run. And again, the reasoning for that is in the other videos. Then the storage cost is 75 cents per item, and there are, on average, 5,000 items in storage. Okay, now the materials cost, that $8, it turns out to not make a difference at all in the run, the size of the runs, but we'll put them in anyway. So we'll do the materials cost is $8 times by, so it's not times by any one of these. It's $8 per item for every single item. So it's $8 times 300,000. So see how this doesn't rely on any of the previous columns. So it turns out to be kind of useless. And it's pretty big. So I just don't even use it. Instead, the part of the cost that matters to me as far as optimizing is it's the storage cost plus the cost of the preference. I'll label that as a cost. So $18,000 for my total cost. Okay, now I could produce bigger batches, do 20,000 items. And if I do that, I need fewer runs. So it's less expensive to do the prep. It's more expensive to store. The overall less expensive total cost. So now I want to copy this down a ways, just until I think I've found a minimum. So 18, 15, 16, back to 18. So I've got a minimum in here somewhere. So I can pick one of these rows. I'll take this one and pull up the solver. Set that cost cell to a minimum by changing the size of the runs, the units per run. Okay, so solver gave me an error, and that's because it couldn't find the solution. And let me show you why. Let's graph the units per run against the total cost, except let me take off my error, just right there, and insert a graph so we can look at it. See, from the graph, I can see that the solution is somewhere around 20,000. And in the data, I can also, let me put this away. In the data, I can also see that there's a minimum somewhere closer to 20,000. So when I started with my solver up here at the highest end of the data, it couldn't find it. It went off in the wrong direction. So let me try solver again. And this time I'm going to start with a value closer to where I think the solution will probably be. So here to a minimum by changing corresponding cell is this one, and solve. Okay, so now close. So now it didn't have trouble finding that 20,000 was the actual minimum. Excel is a machine and it's been programmed and it's trying to do numerical math, and you can help Excel by having it start closer to where you think the actual solution is. So 20,000 items per run.